好啦，各位同學，咁去到咧 Book Five 咧嘅第二課啦。嗱，Book Five 嘅第二課咧就分兩個 section 嘅喎。2.1咧就講 atomic model，咁呢個簡單啲嘅。2.2呢個重要啦，講decay 嘅。咁我哋咧就2.1呢個禮拜講咗先，咁下個禮拜咧就會講2.2㗎啦，應該。咁咧2.1咧就主要講咧 atom 啦、atomic model 啦。今日我哋學嘅 atomic model 咧係點樣嚟㗎啦，係嘛？有個來源啦，OK。咁我哋咧跟住學嗰啲咧咩都唔係好難嘅啫。咁開始講下咯喎 ，atom，OK，咁 atom 係咩嚟嘅咧？咁或者我哋睇下呢個 symbol 先啦。呢個 symbol 大家有冇學過呢個 scientific model 啊？應該啊，咁個個都見過啦，係咪咁啊？應該咁呢個 symbol 咧就代表一個 atom 啦，係咪啊？好啦，咁啊，其實點嚟嘅咧？應該啊，喂，係咪有呢個 science 嘅咧，就有呢個 model 嘅咧？其實唔係嘅喎。咁 atom 咧係好耐之前一個 concept 嚟喎，應該咁就係講緊啲咧遠古嘅希臘人嗰陣時候咧，佢有佢哋嘅 atomic model 嘅。咁 atom 呢個字咧係希臘人製造出嚟嘅。咁咩叫 atom 咧？應該嚇，咁就好多2000年前啦。咁啲希臘人咧就嗰啲哲學家就諗啦，啊嗰啲 solid matter 即係好似一嚿嘢咁啦，或者張紙啦，係咪啊？咁你可以將佢咧分開兩半嘅噃，分兩半，按張再分兩半，再分到咧，佢唔能夠再分啦，最細粒噶啦，冇得再分啦。咁呢一粒咧，我哋叫做 atom 啦，得唔得？應該咁即係個 atom 嗰個概念原來咁嘅喎。將啲嘢你揾張紙出嚟試下啦，將佢撕開兩半，咁啊再撕一半，再撕一半，撕到佢咧，冇啦，冇得再分啦，分唔到噶啦。咁呢個咧就叫 atom。咁當然啦，佢哋點樣分就另外一個問題啦。不過佢嘅概念係咁樣啊，得唔得？咁不過呢個咁嘅概念咧，就直至到咧就係喺呢個1897年啊，咁即係百幾年前啦，就有個人叫 J.J. Thomson， 可能讀 chemistry 嘅同學咧聽過呢個科學家嘅名都唔定啦。咁啊 J.J. Thomson 咧就發現到咧有 electron 啊呢樣嘢喎，係佢發現嘅喎嚇，百幾年前嘅啫。咁呢啲 negatively charge 嘅 small particle 咧就喺邊度嚟嘅咧？就喺個 atom 裏面走出嚟嘅。咁即係話咧 atom 啊唔可以再分細嘅咯喎。atom 裏邊有啲 electron 可以被分出嚟嘅喎，係咪啊？咁所以佢就話啦 atom 咧divisible 可以再分嘅。OK，咁咧佢就製造佢咧就諗下 atom 可以有裏邊有 electron 喎，咁佢個 atomic model 係點嘅咧？應該咁啊右邊呢個咧就係佢嘅 atomic model 啊，同我哋今日呢個咧有啲唔係好同嘅應該啊。OK，不過佢做幾樣嘢嘅，佢就 disprove 咗，即係話推翻咗咧希臘人嗰個 model。希臘人嗰個話咧冇得再分細㗎啦，最細就係 atom 㗎啦，應該佢就話唔係 atom 裏邊咧就包含有啲咧叫做帶負電嘅嘢，叫做 electron。OK，佢 propose 咧 electron 就點咧？就好似咧就一個positive charge 嘅裏邊咁樣，然後咧就裏邊有啲 electron。咁有啲人咧講咧叫做咩 model 咧？叫 raisin bun 啊 ，raisin 即係提子，bun 就一個包。咁你想象下咧，就一個麵包。一個麵包裏邊咧有啲提子，啲提子咧就係啲 electron 啦，係咁樣分佈嘅喎。而啲麵包咧就係嗰啲 positively charge 嘅 substance， 得唔得啊？咁即係滿佈喺呢度嘅。咁呢個咧就係J.J. Thomson 佢發現到 electron， 知道 atom 裏邊咧有 electron 嘅，去 propose 出嚟個 model。OK， 好啦，佢 propose 出嚟啦，咁佢有個學生噶嘛，個學生咧就叫做 Rutherford。咁 Rutherford 咧就想咧J.J. Thomson 就話啦，不如你幫我做個實驗啦，實驗咧證明我 model 係啱啦，係咪咁應該？咁咧就Rutherford 就好啦，應該Rutherford 係佢學生嚟噶嘛。好啦，咁Rutherford 咧就帶住兩個人啊，呢個一個叫 Geiger， 一個叫 Masterson 係咪啊？咁 Geiger GM tube 咧就係呢兩個人嚟嘅，同Rutherford 一齊去做嘢嘅。Under the supervision of 呢個Ernest Rutherford 咧，咁一齊做咯喎。咁呢個咧就係佢設計嘅實驗嘅。佢設計實驗係點嘅咧？應該咁一陣間有個 link 嘅喎，喺個 YouTube 裏邊咧，我發覺呢個片咧相當之好啊。咁所以我一陣撳出嚟啦，我驚你想睇翻嘅話咧，咁你去揾翻呢一個 YouTube 呢個嘅嘅 link 去揾翻都得，明唔明意思啊？咁咧或者個 video 咧，你撳唔到嗰個 link 嘅，因為個 video 咧就冇得撳噶嘛。咁你去翻個 PowerPoint 裏面撳都得，好唔 OK 啊？嗱，咁我講翻啲實驗先。呢個實驗嘅設計係咁樣，佢咧就揾一個 radiation alpha source， 呢個放啲 alpha particle 出嚟嘅。咁啲 alpha particle 咧就放出嚟啦，跟住就想打埋落啲 gold foil 一個金箔上高。咁金箔咧就係一個好 metal 嚟嘅，好穩定下嘅。咁跟住咧揾啲佢咧可以揼到好薄嘅應該。咁根據Thomson 嘅 model 咧，好似個 atom 咧就係啲 electron 喺中間。 咁而有啲正嘅嘢咧，嗰啲 substance 咧就均勻地分佈咧，實在個力係好細嘅啫。咁佢期望咧就所有嘅 alpha particle 由個 radiative source 走出嚟嘅話咧，就能夠穿晒過去另外呢邊，即係咁樣嘅應該。咁當然啦，因為佢用 alpha 組嘛，呢個 environment 咧一定要真空先得啦。如果滿布空氣，根本 alpha 都行唔到5cm，咁啊冇意思啦，係咪啊？咁所以佢抽咗真空嘅呢度 ，OK 咁樣咯。咁我哋有個 YouTube 個 animation 啊，都幾好睇嘅應該嚇，我哋 click 過去睇睇咯應該。
必理痛有效止痛，對身體溫和，24小時排出體外，不殘留。
The plum pudding model of an atom was one of the most widely accepted models all over the world for understanding the structure of the atom. However, several experiments performed by scientists to study the atomic structure showed astonishingly different results. They were contradicting the plum pudding model. This led many scientists all over the globe to reconsider the structure of an atom and study it again. Around the year 1911, a British physicist, Ernst Rutherford, carried out the famous gold foil experiment. He did this to understand the structure of an atom. The experiment was carried out by Rutherford along with Hans Geiger and Ernest Marsden. The experiment he performed was a breakthrough in the field of chemistry which helped him understand the structure of an atom in a more accurate manner. This is how the setup of his experiment looked like. As we can see here, he used a source of alpha particles locked in a lead container with a very small slit. This ensured that the alpha particles only came out through a small opening and travelled in a straight line. But why did he select alpha particles in the first place? Well, the alpha particles were having high energy and were heavier as well. So if we say the atom is like a pudding of positively charged particles with electrons embedded in it, then the particles will pass straight through it. This is obvious because the heavier particles will pierce through the lighter pudding structure of the atom and pass through it. This is what Rutherford thought. For this reason, their greater mass and energy compared to the protons made him choose alpha particles for the experiment. Next, he used a very thin gold foil on which the alpha particles would bombard. Why did he choose a gold foil? Well, a really thin gold foil was estimated to contain approximately 1000 atoms. Lesser the atoms, more convenient the experiment would be. Lastly, are we able to locate this circular band with a gap here? What could this be? Well, this is the screen. A fluorescent screen that would help us detect the radiation. That means the screen will glow or emit fluorescent light whenever alpha particles will hit it. So this is how the track of alpha particles can be traced. Now we're all set to understand how the experiment worked. The alpha particles were emitted from the element present in this box. These directly hit the gold foil. Now what should happen ideally? As we know, the Thomson's model suggested that an atom is a sphere of positive charge with negative electrons embedded inside it. That means it is expected that the alpha particles will pass right through the atoms and hit the detector straight. And why so? Because the mass of alpha particles is heavier than the mass of positive charges. That means they should directly hit the atom and move ahead through it. Only a very small deviation would probably be acceptable in this case. But is this what he observed? Not really. He was astonished to get unexpected results. What results did he get? He found that most of the fast-moving alpha particles passed straight through the foil and hit the detector. However, some particles got deflected by small angles. And lastly, to his astonishment, few alpha particles also rebounded. Now, how can this be possible? These three observations made Rutherford think that the plum pudding model is not really correct. Based on the conclusions he had, he put forward the new hypothesis explaining the structure of atoms. What were his conclusions? Let us have a look at the conclusions by Rutherford, followed by the new atomic model put forth by him in the next video.
好啦，咁呢個咧就係嗰個 video 咧，就係第一個咧講下 Thomson 嘅 model 啦，咁係乜嘢做咗啦，咁然後咧就揾到啲咩結果出嚟啦。咁我哋睇睇呢個先，一陣再睇下 Rutherford 佢 propose 出嚟佢個 model 係點咧 ？OK 得唔得？好啦，咁我哋講翻啦，咁J.J. Thomson 咧就 propose 佢個 model 咧叫 plum pudding 即係好似個布丁，咁有啲 plum 喺度咁係咪啊？啲 plum 咧就分佈咗喺個 pudding 上高，就好似啲 electron 咁樣啦，得唔得啊？咁或者有啲人叫 raisin bun 提子包，咁個概念都一樣嘅，即係話咧嗰啲 positive 啲叉出咧就好似個包咁樣均勻地分佈喺個包嗰度，然後啲 electron 咧就 embed 咗喺嗰個包裏邊 ，OK？ 咁Rutherford 咧就聽阿 Thomson 講啦，就做呢個實驗啦，係咪啊？咁做咧就揾呢個 alpha 咧就射埋個高 foil 裏邊啦。咁揾到結果點咧？結果咧頭先個 video 有講嘅，咁我哋講下啦，應該啊。咁我哋期望啊，佢最初期望咧就係所有嘅 alpha particle 咧應該就係直過晒去，走晒過係 undeflected 嘅。有少少咧，因為呢度可能有少少嘅 deviation 啦，撞幾次係咪啊？有 small angle 嘅 deviation 咧都係 acceptable 嘅，得唔得啊？不過咧揾到出嚟就未必係嗰個情況咯。雖然 nearly all the alpha particle passes straight through the foil， 好大量都係過咗去嘅，好大量過咗去，呢個啱嘅。不過有一啲咧就會 deflected 咗，個角度都比較大嘅喎，咁都可以理解啦。會唔會咧 deflect 好多次？因為咧嗰個高 foil 裏邊咧都有好多層唔同嘅 atom 噶嘛。好啦，咁結果喺呢度啦。最解釋唔到嗰啲咧就有啲咧就 even bounce backward， 咁呢個咧就解釋唔到嘅，得唔得啊？解釋Thomson 嘅 model 咧係解釋唔到嘅，咁所以咧呢三個咧就係去揾到出嚟個結果 ，O 唔 OK 啊？得唔得？好啦，咁Rutherford 係點咧 ？Rutherford 就 propose 佢個 model 咯，即係 Thomson 嗰個唔 OK 嘛。雖然係老師啫，老師講錯嘢，咁又實驗揾唔到出嚟嘅結果，咁唔得噶嘛。Rutherford 咧就 propose 佢個 model 啦。咁佢個 model 咧就有點樣咧？佢就話咧以下呢幾點嘅，咁我哋睇完個 video 翻嚟再討論下，好冇
？Rutherford's gold foil experiment gave him interesting results. What results did he get, by the way? Let me recall them for you. He found that most of the fast-moving alpha particles passed straight through the foil and hit the detector. However, some particles got deflected by small angles. And lastly, to his astonishment, few alpha particles also rebounded. Now, how can this be possible? These three observations made Rutherford think that the plum pudding model is not really correct. Let us take a simplified example to understand the inferences first. Let us imagine that we have a ball made up of cotton. The cotton in the ball is very sparsely distributed and has an extremely tiny circle or sphere located at the center. This sphere is quite hard and dense. So hard that it can even resist a bullet shot against it. Now what will happen if you shoot many bullets across this cotton ball? Most of them will travel straight through the cotton surface. What will happen if a bullet hits the edge of the central heavy mass? In this case, the bullet will slightly change their path and get deviated. So looking at the size of the central mass, it's obvious that only some of the bullets will get deviated. Lastly, what happens when a bullet hits the center directly? Needless to say, it will bounce back, because we know that the central dense mass is too hard for the bullet to pass through. So very few bullets will bounce back. This is analogous to what Rutherford had inferred about the atomic structure. His first conclusion was that most of the space inside an atom is empty. This is because most of the alpha particles could easily pass through the atoms and hit the detector straight. Now, if most of the space is empty inside an atom, then where is the positive charge located? Well, that's the second conclusion. The positive charge is compactly packed in a tiny entity. This occupies an extremely small space inside the atom. Now, why did he think so? Let's go back to our cotton ball and bullet example. Can you recall the second and the third case? Yes, the bullets get deviated on hitting the tiny sphere of the edge, and they will rebound when they hit the center. Same explanation holds true for this. A few alpha particles get deviated. That means there is a possibility that these hit the edge of the positive center. Yes, and one more possibility is that they get deviated because the positive center repels the alpha particles as they're also positively charged. Also, a very small number of alpha particles rebounded. That means there is a possibility that these alpha particles had directly hit the positive center. But since the number of these rebounding particles is too small, it explains that the volume occupied by the positive center is also very small. If the space occupied would have been big enough, then the number of alpha particles bouncing back would also be greater. So let's say there are gold particles in the foil. He found that most of the rays pass straight through the atoms. A few rays change their path and get deflected. Lastly, very few particles bounce back. These results compelled Rutherford to come up with a new nuclear model. Let's have a look at the hypothesis put forward by him. Firstly, there's a positively charged center in an atom called nucleus. Nearly all the mass of an atom resides in the nucleus. Secondly, the electrons revolve around the nucleus in circular paths. Thirdly, the size of the nucleus is very small compared to the size of an atom. However, theoretically, there were many flaws in the hypothesis. Let's have a look at the drawbacks in Rutherford's hypothesis in the next video. Also, we will have a look at the explanation of atomic structure by another scientist named Niels Bohr in the next video.
好啦，咁睇咗個 video 啦，係咪啊？咁就講咗咧，就係 Rutherford 咧 ，based on 佢個 experimental result 啦，再 propose 佢個 model 啦，係咪啊？好啦，咁我哋講咗你先。不過最後尾一個部分咧，就發覺，咦，阿 Rutherford 個 model 都唔係 OK 喎，係咪啊？仲有一個叫咧阿 Bohr 咧，佢有一個 model 嘅喎。咁不過咧 ，Bohr 個 model 咧，我哋喺 Book 5咧係唔會講嘅。咁但係我哋會喺個 extension 咧，喺個 Atomic World 嗰度咧，我哋會講嘅。我哋遲啲會睇翻嗰個嘅。咁所以咧，如果 Book 5咧 core 部分咧，我哋 up to this point 就夠啦，明唔明我意思啊？咁再有 further 嘅 development 嘅，例如咧，個 atom 裏邊有 neutron， 其實 Rutherford 冇講嘅喎，佢都未發現到 neutron， 係咪咁應該？咁所以咧，佢咧淨係話咧嗰啲 positively charged 嘅 substance 咧就 confine 咗一個 tiny core， 個 core 就叫 nucleus 咁嘅解啫，得唔得啊？好啦，我哋咧不如咁啦，就睇翻阿 Rutherford 嗰個 conclusion 或者佢個 model 啦，因為咧要 rebound 嗰啲嘅 alpha 啊嘛。咁要集中啲 positive charge repel 佢先得，夠強先得㗎。咁佢第一個 propose 咧就話 all the positive charge of the atom 嗱 all the positive charge 所有嚇 and most of the mass， 因為點解咧？仲有啲 electron 喺出邊，主要嘅 mass will concentrate in a tiny core。個 tiny core 咧，佢俾個名佢叫 nucleus， 得唔得？好啦，第二個咧。咁啲 electron 喺邊啊？咁有 electron 噶嘛 ，Thomson 揾到出嚟噶嘛，係咪？咁 electron 咧就 orbit around the nucleus， 得唔得啊？咁氹轉，咁咧正嘅咧就喺裏邊，咁咧負嘅咧就喺外邊 orbiting， 得唔得啊？咁加埋就 neutral 咯。咁咧其他啲咧，其他啲就係 empty space 嚟㗎，冇棉花㗎嚇，得唔得？棉花係佢咧嗰個 model 嘅解説嘅啫，應該。咁就係咁多嘢㗎啦，明唔明佢意思啊？咁啊空溜溜嘅喎。嗰個 nucleus 咧係好細嘅，相比於嗰個 atom 嚟講咧係細得好緊要嘅，得唔得啊？否則咧咁嗰啲 derivative 角度大嗰啲啊 rebound 嗰啲咧就會好多嘅咯喎，但係實際上咧 rebound 嗰啲啊唔係好多嘅啫，O 唔 OK 啊？咁呢個咧就係 Rutherford 或者我哋今日咧可能會認識到個 model，O 唔 OK 啊？我認識再多少少啦，因為點解 nucleus 裏邊咧可以再分嘅，分做 proton 同埋 neutron 係咪咁應該？咁其實咧仲有冇其他嘅 further development 咧？坦白講係有嘅。得唔得啊？啊！如果不過我哋 DSE 就去到呢個位置啦。electron 可唔可以再分啊？其實可以再分嘅，不過嗰啲咧可能入到大學，大家先會讀都唔定啦。OK， 好啦，咁啊解釋點解佢 propose 呢個咧？咁頭先講咗啦，因為咧當 alpha 咧係蹦巴，即係撞到呢個高科嘅話咧 ，most pass straight through the empty space， 大部分都直過嚟嘅喎。咁點先可以直過咧？咁好多 empty space 咪直過咯，係咪啊？呢個第一個可以解釋到啦。第二個咧，如果有啲咧好近嘅話咧，咁佢就會 repel by 個 electrostatic force， 就會 deviate 一個 angle 咯，係咪啊？嗱，解釋第一部分 most 咧就係 undeviated 嘅，得唔得啊？咁有啲咧就 deviate 一個大嘅角度都唔定啦。咁最難解釋到嗰啲咧就 Rutherford 都解埋啦，用呢個 model。咁就有啲咧打到正嗰個 nucleus 嘅話咧，咁就 even bounce backward 反彈翻轉頭。 如果用阿 Thomson 嘅 model 咧，咁你 positive charge 咧係均勻分佈啊嘛，係冇呢個力量咧可以將咧好重好 high energy 嘅 alpha 咧撞翻轉頭嘅。咁但係 Rutherford 個 model 咧就可以啦， OK 啊？咁所以咧有3個 observation 就係 most undeflected 嘅 alpha radiation， 有一啲 deflect 一個角度嘅 small angle 係咪啊？有啲 bounce backward 嘅，咁就得出我哋有嗰3個 conclusion， OK 啊？咁呢3個 conclusion 咧就係好多咧都係 empty space 啦，咁然後有個 tiny core 咧就 contain all the positive charge and most of the mass 喺裏邊嘅。咁而 electron 咧就 orbiting around 嗰個 nucleus 啦，因為佢要 neutral 噶嘛，應該 OK 啊？咁我哋咧就係呢個就係 Rutherford 個 model 啊。好啦，嗰個 nucleus 你話好細啦，係咪啊？咁幾細咧應該啊 ？Rutherford 做啲數學嘅喎，唔係齋噏嘅喎，係咪啊？咁要齋噏就唔得啦。咁佢就話咧好細嘅，細到幾多咧？就大約係如果個 atom 嗰個 size 咧係10嘅負10次方個 meter，10嘅負10次方 meter 個 radius。nucleus 咧就係10嘅負14次方，10嘅負14次方，得唔得啊？應該咁啊，我哋咧大約啦，佢又話咁啊，如果個 atom 嘅 size 咧就係嗰個會議展覽中心啊，得唔得啊？咁個 nucleus 咧就係一粒豆咁上下啊，大家每個會展啊，應該嗱，如果冇咧，我亦都可以做一個比喻喎，應該啊。頭先我講咧就係 atom 嘅 radius 就係10嘅負10 meter， 咁啊 nucleus 就係10嘅負14個 meter。係咪爭咗10嘅4次方啊？咁你想象下咧，就喺天水圍運動場100米嘅跑道係咪？中間擺個一毫子，咁嗰個就係 nucleus 啦，得唔得啊？嗰個一毫子同埋個運動場嘅外圍咧，其他全部咧都係 empty space 嚟嘅，得唔得啊？咁係咪真係好細啊？應該係咪？咁呢個咧就係嗰個 model 啦，應該。咁你有個animation 睇唔睇到先？你講呢個。
This model can be used to simulate how alpha particles are deflected in the scattering experiment. When released at different heights, a ball bearing approaches the hill at different speeds.
打到正咧就翻轉頭。
Notice how the ball bearing is deflected.
如果撞到中間呢個 Rutherford 嘅 model 咧，就可以 rebound at
How is the angle of deflection affected by the speed of the ball bearing?
佢有唔同嘅速度咁樣 ，OK？ 好啦，咁呢個咧就係一個簡單嘅 animation， 咁啊個 video 好似好睇啲嘅 ，OK？ 好啦，咁我不如試下做一條先啦，好唔好？應該佢就話啦，有個 alpha particle 啦 is fired at the thin gold foil， 好似你咁樣啦，應該。咁 it is deflected when it approach 個 nucleus。咁點解咧？因為個 nucleus 係正噶嘛。咁呢個 alpha 都係正嘅噃，係咪啊？正同正咧之間有一個 electrostatic 嘅 repulsion 就會deflect 咗過去向呢邊啦，留意喎，兩個都係正嘅，會 repel 嘅 ，O 唔 OK 啊？咁啊問你第一個啦 ，Why is the alpha particle deflected？ 咁如果頭先你明啦 ，OK 啦，因為 alpha 係帶 positive charge 噶嘛，而個 gold atom 嘅 nucleus 咧都係 positive charge 嘅喎，咁因此咧兩個都係 positive charge， 咁所以佢哋 repel by 一個 strong 嘅 electrostatic force， 得唔得？ O 唔 OK 啊？咁關鍵就在於兩個都係正嘅 ，O 唔 OK？ 得唔得啊？好啦，咁啊 alpha fire repeatedly 啦 ，most of them goes through 嗰個 gold foil 咧 without deflection， 大部分都係直過嘅喎，冇 deflection 嘅喎，點解咧？好啦，因為咧個 atom 係點啊？個 atom 咧 most of the space is empty space， 大部分都係空溜溜嘅，得唔得啊？咁所以咧佢就能夠直過咗個 gold foil without deflection， 得唔得啊？如果佢唔係去到個 nucleus 咧？去到 nucleus 好難噶嘛，應該因為 size 比較細啊嘛，咁所以大部分咧都係直過嘅，有少部分啦，有幾少咧？大約啊，如果係 Rutherford 嗰個數據咧，我如果冇記錯咧，就大概喺800萬個嗰個observation 裏邊咧，800萬個嗰個 collision 裏邊咧，咁就有3個有 deflect 到嘅啫。嗱，佢真係數800萬個㗎，如果唔係嘅話咧，你要做10個啊，做20個咁又唔睬你㗎，應該得唔得？應該 OK 有問題啊？好啦，咁呢個咧就係嗰個結果啦。好啦，咁咧有個 class practice 喎，1至4喎，咁啊同學可以試一試啦。呢個 O 唔 OK 啊？咁應該都唔係好難嘅，應該係問翻嗰個 Rutherford 嗰個 model 啊，嗰個實驗啊嗰部分啫，應該咁應該要試下識下嘅，得唔得？好啦，咁咧跟住咧就講下個 atomic structure 咯。Rutherford 講咗一部分啦，咁我哋今日學嘅咧就多過 Rutherford 識嘅嘢啦，係咪啊？因為我哋又識 neutron 啦 ，Rutherford 唔識嘅喎 proton 啦 ，Rutherford 都未發現嘅喎，佢就話嗰嚿嘢係正嘅啫，就咁簡單，咁 OK 啊？好啦，咁我哋咧就温下我哋以前可能 Form 3學過 chemistry 裏邊嗰啲嘅 atomic structure 啦。好啦，咁咧呢度點嘅咧？就話咧，如果你 further investigation 咧，就係 nucleus 裏邊咧係其實包含咗 proton 同埋 neutron 嘅，就好似我哋呢個 model 咁啦，明唔明意思啊？嗱，我睇下呢個先，呢個咧有3粒正嘅，3粒正咧。呢個咧就係 proton 3個 proton， 咁亦都有翻3粒負喎，係嘛？3粒 electron 係 orbiting around 嘅，得唔得？好啦，咁跟住咧結果就係 neutral 啦，有4粒呢個咧 neutral 嘅咧就係 neutron 啦，好唔 OK 啊？咁我哋成個咧叫一個 atom， 而裏邊呢個咧就叫做個 nucleus， 得唔得？好唔 OK 啊？好啦，温下啲嘢先啦。atom 個 size 係幾多咧？個 size 咧，如果個 radius 咧就係10⁻10次方左右。嗱，呢個唔一定係㗎，呢個嚇。譬如你 hydrogen 咁佢係細啲啦。譬如你 uranium， 即係或者你lead 嗰啲嗰個 mass number 係206啊嘛，係咪啊？咁而 hydrogen 係1啫嘛，咁嗰個咧lead 嗰個咧會大粒啲㗎，應該嚇。好啦，咁個 charge 係幾多咧？應該個 valence charge 咧就係冇嘅，因為佢基本上係 neutral 㗎嘛，得唔得啊？好啦，個 mass 咧就係 Z 加 n，Z 咧就係proton 嘅數量，我哋用呢個 symbol 㗎嘛 ，n 咧就係 neutron 嘅數量。得唔得啊？主要咧就係 proton 再加 neutron 嘅 mass， 咁你可能加埋 electron 嘅 electron 咧，不過個 mass 咧相比呢兩個咧就細好多啦，大約係1比1836 ，OK 得唔得？應該1比1836 ，OK， 咁呢個就係咁樣嚇 atom 嘅成個嚟睇。好啦，咁啊裏邊呢個叫咩啊？裏邊呢個叫做 nucleus 啦，係咪啊？咁個 size 咧頭先講咗啦，10⁻14次方左右。咁當然啦，有啲 variation 嘅，不過大約呢個數字啦，得唔得啊？好啦，又帶唔帶電啊？今次 atom 成個就 neutral 嘅喎，咁佢帶電㗎，係咪啊？佢帶正電定負電啊？正電㗎，正幾多啊？正有得揀，正 Z 啦，正 N 咧，咁啊正 Z 啊，得唔得啊？應該，因為 Z 係個 proton 嘅數量啊嘛 ，proton number 得唔得啊？好啦，個 mass 係幾多咧？個 mass 基本上同個 atom 係差唔多嘅，輕啲啲，爭啲 electron，咁我呢度 Z 加1啦，Z 加 n 啦 ，sorry， 得唔得？應該。好啦，咁啊正呢粒咯，正粒有個名啦，呢個名叫做 proton 啦，係咪啊？咁佢 size 咧 size 更細啊，應該啊10⁻15啊，得唔得啊？因為呢個咁樣-14啊，得唔得啊？咁佢帶唔帶電咧？就帶電啦，帶1個單位，嗱一唔係一個 coulomb 喎，係1個單位，一個單位即係話咧一個 electronic charge 1.6乘10⁻19次方個 coulomb，佢係正嘅，得唔得？咁個 mass 咧都係正嘅，1咧，我哋叫1，得唔得啊？個 mass，咁1即係幾多咧？我哋叫做1個 atomic mass unit。咁如果你查嗰個data book 咧，會有寫嘅1.67乘10⁻27次方個 kg， 得唔得啊？我哋用1個單位，1個 atomic mass unit，OK？ 好啦，咁proton 講咗咯，呢一粒啦，灰灰地色呢粒啊，冇 charge 嘅喎，呢粒就係 neutron 啦。咁個 size 咧同 proton 差唔多嘅，咁咧佢個 charge 咧當然係冇 charge 啦 ，neutral 噶嘛。好啦，個 mass 咧同 proton 差唔多嘅。最重個 proton 少少，不過爭好少啫，得唔得啊？好啦，最後尾electron 啦 ，electron 個 size 就細好多啦，係咪啊？佢就唔係10⁻15次方啦，佢係10⁻18次方啊，得唔得啊？再細好多啊 ，electron 再細粒啲，佢帶唔帶電？帶電，帶1個單位負嘅。好啦，個 mass 咧就接近0啊，就叫做0啦，不過事實上就唔係0嘅，佢個 mass 咧就係 proton 嘅1836分之一。咁呢個數值咧，嗰個data 有嘅9.11乘10⁻31次方個 kg， 得唔得啊？咁我哋咧就知道呢啲咁嘅資料。咁應該可能你中3學過都唔定啦，不過幫你溫下書啫。好啦，咁呢個就係 proton、neutron 啦，統稱啊，呢啲叫 nucleon。你話 nucleon 係咩嚟嘅咧？即係 proton 同埋 neutron 嘅統稱啊，唔可以係 proton， 可以係neutron 一個 collective 嘅name 嚟㗎，得唔得啊？咁差唔多係 same mass 嘅 neutron 重少少，不過差唔多嘅啫。好啦，咁electron 咧就輕好多嘅，好唔 OK 啊？就 orbiting round 嗰個 nucleus，OK？ 好啦，呢個咧就係 atomic number 同埋 mass number 啦喎，記唔記得你 Form 3 chemistry 學嗰啲嘢啊？應該咁咧，我哋又由唔同嘅 proton 同埋 neutron 所組成啦，係咪啊？咁咧 proton 咧喺個 nucleus 裏邊咧就叫 proton number。 或者叫 atomic number。OK， 好啦，咁啊有啲 symbol 我哋學過應該嚇，咁你個 hydrogen 啦、helium 啦、carbon 啦，如此類推啦。嗱呢啲未必學過啦。radon 氡氣啊，一啲 gas 嚟嘅，對有人體有害嘅。radium 會 radioactive 嘅。actinium 呢個嚇 ，fluorine、protactinium 同埋 uranium 大家會識啦。咁個 atomic number 咧就會唔同啦。嗱你見到咧就82以上，嗱82係叻啊，以上呢啲咧基本上都係唔 stable 嘅 radioactive 嘅。得唔得啊？應該呢啲，我哋最熟悉可能你係92啦 ，uranium 鈾元素啦，係咪聽過呢個啊？好啦，呢啲就係一啲 element 同埋佢嘅 atomic number，OK？、好啦，咁啊，如果係 proton 同埋 neutron 加埋 number 咧，我哋可以叫 mass number 或者叫 nucleon number，OK 得唔得啊？我哋用呢啲咁樣嘅 symbol 去代表佢喎，嗱要識寫呢個喎。好啦，我哋試一試先啦。Z 咧就係 atomic number， 即係 proton 嘅數量。A 咧 mass number 咧就係 proton 再加 neutron 嘅數量，得唔得啊？咁個 symbol 我哋會咁寫嘅，嗱要識寫呢個 symbol 啊。X 咧係代表嗰隻 element，Z 咧就係 proton number， 即係 proton 嘅數量。A 咧就係 proton 再加 neutron 總嘅 nucleus 裏邊有幾多？咁 number of neutron 就係幾多咧？呢個 A 減 Z 就係 neutron 啦，得唔得啊？好啦，我哋試下做一做啲例子，睇下會唔會明白啲。咁 hydrogen 咧係第一個 element 嘛應該，咁所以佢個 atomic number 就係1啦。咁啊 hydrogen 咧，如果我哋有好多 isotope 嘅，最簡單一個咧就係冇 neutron 嘅，所以呢個都係1。你話係咪一定嘅咧？唔係喎，我哋做一啲 isotope 咧，譬如有個 deuterium 啊、tritium 嗰啲咧，可能有 neutron 都唔定嘅。不過我哋最簡單平時講開個咧 hydrogen 咧係得 proton 嘅啫，就冇 neutron， 所以呢個都係1。O 唔 OK 啊？咁點寫咧？因為個 atomic number 係1。mass number 都係1，咁所以就寫1 H 咁用呢個 symbol 係咪啊？代表佢有一粒 proton， 咁一粒 proton 就冇 neutron， 得唔得啊？應該好啦，所以 neutron 咧就呢兩個相減咧就係0啦。O 唔 OK 啊？嗱，我哋嗰個 structure 就咁啦，一粒 proton， 一粒 electron， 中間裏邊冇 neutron 嘅。O 唔 OK 啊？呢個就係最簡單嘅 element。OK， 好啦，第二個 element 啦喎。第二個 element 就係 helium 啦，第二個啊嘛，咁有2粒 proton 啦 ，atomic number 就係2，mass number 咧，喂佢有 neutron 嘅喎。如果 helium 一般正常咧就係2粒 proton， 2粒 neutron 係咪啊？我哋好似 alpha particle 啊嘛應該，咁所以2+2呢個就係4嚟嘅噃。咁所以個 symbol 咧就係左上角係4，下低係2，寫 He， 嗱呢個就係 symbol 啦。O 唔 OK 啊？咁我知道你 chemistry 咧係咪有人背20個㗎？背20個有首歌噶嘛，係咪啊？咁你應該識唱啦，應該。好啦，咁如果我哋知道呢個4呢個2咧，4減2咧 ，neutron 就係2粒啦。OK， 嗱呢個就係嗰個 atomic structure 啦，得唔得？應該。好啦，呢個咧有2粒 electron 喺出邊，裏邊有2粒 proton 同埋2粒 neutron， 明解唔明解？得唔得？好啦，咁第3個 element 咧就係 lithium 啦 ，lithium 咧就係3啊，係咪啊？lithium 咧個 mass 係幾多咧？有唔同 isotope 啦，我哋最講簡單個咧就係7嚟嘅應該。7即係意思咧，就即係話佢有3粒 proton， 但係有4粒 neutron 係咪啊？我哋 symbol 點寫咧？咁我哋左上角呢個咧係寫個 mass number 啊嘛，所以就7、3，然後 Li， 呢個就係佢 symbol 啦，得唔得啊？咁個 neutron 數量就7減3啦，等於4啦，係咪？呢個就係咁啦。我哋數喺入邊啦，話我唔數啦應該嚇。咁有3粒 electron、3粒 proton、4粒 neutron， 得唔得啊？嗱，如果 isotope 咧 proton 嘅數量一樣嘅，個 difference 咧就係有唔同嘅 neutron 嘅數量啫，得唔得啊？應該。咁如果係 lithium 咧，第3個 element 咧一定係3粒 proton 嘅，冇得揀㗎啦。O 唔 OK？ 好啦，咁呢個就係啲以前學過啦，係咪啊？好啦，咁我哋咧有啲名 nuclei 即係話咧，任何嘅 nucleus 咧統稱叫 nuclei 啫。OK，a nucleus of a particular mass number atomic number， 咁我哋叫呢個叫 nuclei， 得唔得？應該。但係有啲 nuclei 咧，有啲嘢咧就會放射性嘅喎，我叫 radio nuclei， 呢個係 radioactive 嘅 nuclei， 得唔得啊？應該 radio nuclei 就咁樣講，OK 得唔得？譬如 carbon 12咧就冇乜特別嘢啦，係咪啊？咁所以咧我哋 carbon 咁 12 嗱 carbon 就即係第幾個 element 咧？第6個。咁所以我哋6我哋唔會寫俾你嘅喎，因為 carbon 係第6個啊嘛。12咧就係佢個 mass number 啦。咁 carbon 可以有另外一個嘅 isotope 嘅喎 ，carbon 14咧 都係有6粒 proton，但係有8粒 neutron，所以加埋就係14，得唔得啊？咁嗰個咧就係有放射性嘅 radioactive 嘅 nuclide。OK， 好啦 ，isotope 就係頭先我哋講呢個啦 ，element of same number of proton but different number of neutron 係咪啊？譬如我哋講呢 hydrogen， 平時講呢個 hydrogen 1啦 ，hydrogen 2咧就 deuterium 咧就有呢個啦。咁我哋頭先講個 carbon 14就喺呢度啦，得唔得啊？咁所以大家都係 carbon 就係6啦，唔使講啦 ，proton number 係6粒 proton， 咁但係咧嗰個 neutron 嘅數量咧就會有啲唔同。咁呢啲係一啲 radioisotope 嚟嘅，有放射性嘅。OK， 咁呢個兩個名我估你應該都識，不過溫下書咁解啫。咁啊試下 checkpoint 咯喎，好唔好啊？應該好啦 ，checkpoint 咧大家試下 page 47， 1、2兩條，好唔 OK？ 嗱，你撳停佢試咗先，好唔 OK 啊？好啦，我當你試完啦喎，應該嚇，呢個都好易嘅啫，應該嚇，得唔得啊？好啦 ，name 個 structure one， 我即係話呢個要唔會出啦 ，DSE 係咪啊？要係咪發達啦？一咧梗係叫做嗱一唔係叫 nucleus 喎，成嚿嘢呢個係一咧應該係 proton 啦，係咪啊？二咧就係 electron 啦，三咧就係 neutron 啦。我估 form 3就都未必出啦，高 chain 係嘛？好啦，呢個四咧就係 nucleus 啦，得唔得啊？好啦，咁可唔可以話俾你聽咧？2同埋4啊，嗰個 electric charge 幾多咧？2係 electron 啊嘛，咁就係負一就即係負 1.6 乘10嘅負19次方個 coulomb，得唔得啊？好啦，咁啊4咧，4係呢個喎，4咧就數下啦，1、2、3有3粒正嘅，咁所以個 nucleus 咧就係 4.8 乘10嘅負19次方 coulomb 正嘅，得唔得啊？應該咁呢個都唔難到你啦。好啦，呢個表，哇！呢個表應該就即係 check point 呢啲嚇。好啦 ，carbon 嗰個 number proton 咁啊，梗係6啦，係咪？如果 mass number， 呢個唔同喎，呢個唔係 carbon 12喎，呢個 carbon 13喎，咁所以 neutron 就係7啦，得唔得啊？咁個 notation 點寫啊 ？notation 即係話咧，我哋用左上角、右上角mass number、atomic number 嗰個點寫咧？咁啊，左上角就係13啦，右下角就係6啦。左下角就係6啦，咁呢個就係 carbon， 得唔得？呢個係 isotope 嚟㗎，呢個得唔得？好啦，咁呢個跟住咯喎，咁而家呢個 proton 53，neutron 74，咁所以 atomic number 咧都係53，照跟翻個 number proton 得啦。mass number 咧就係呢兩個嘅總和啊 ，mass 啊嘛係咪啊？127，好唔 OK 啊？好啦，咁我哋寫個 symbol 咧，左上角呢個咧就係 mass number 127，左下角呢個咧就係 atomic number。53，所以127 53拗電得唔得啊？應該好啦，咁呢個咧你睇呢個 symbol 咯喎，嗱睇呢個 symbol 咧，呢個係90，所以 atomic number 係90，mass number 咧係238，好唔 OK？好啦 ，proton 嘅數量咧就係90，neutron 嘅數量咧相減呢應該係148，好唔 OK？應該咁呢條咧就係兩個 check point 得唔得？好啦，咁class practice 咧同學自己試啦，好唔 OK 啊？5至10。應該都唔難嘅，都輕鬆嘅嘢嚟啫。OK， 好啦，咁試下做個 practice 嘅2.1啦，係嘛？呢個咧 section 都係唔算太難嘅，簡簡單單。OK， 好啦，我哋講到呢度為止咯喎。OK， 好啦，同學要努力啦，今個星期嚇。OK， 好，拜拜。